All right. Well, welcome to week 2 of the AI for environmental researchers. Last week was sort of theory and high-level contextualization of where we're at. Today, we're just going to talk about a workflow. I wanted to do a real-time demo where I just put in prompts and we do this all together. And then I got too carried away and did too much stuff and can't get through all the prompts. So it's more like a cooking show now where I show you, if you mix this and you mix this and you mix this, and then you put it in the oven and then I'll pull out a fully baked cake. And so you guys can feel free to carry along, cruise along with me. I'll be cruising through a couple of the platforms and I play along, do some chat and some prompts. They'll just be probably a little shorter than the ones I have on the slides. But I think this should be fun and interactive. So please feel free to have your AIs open and cruise along if you would like to. Again, my name is Tuff. I am the data scientist for ESL. So our conceptual model for getting through today is going to be our id, our ego, and our superego. So we're going to break the tools into these three things. So our id is going to be where we think internally. So this is our searching for ideas, thinking through things, synthesizing different ideas. This is our conversation. Our ongoing conversation is with id. Our ego is about doing things. It's about getting stuff done, about building code, making things happen, making images happen. And then the superego is about verifying that, about showing it to the world and about it being the veneer that shows you. And so you have to be really careful with that one. So how did this start? So I'm going to walk you through one research project using all AI. And this started last week at the firing meeting. Kyle presented his work on the WUI, and there was this WUI boundary. And I had this idea that that was a lot like this Mandelbrot paper about how long is the coastline of Britain. And the answer was, depends on how long of a measuring stick you use. And they said, we use a lot of satellite data with a lot of different measuring sticks as raster cubes. There's probably some fun analysis we could do. So on my phone, and so this is my first suggestion, is the app and particularly voice mode is really useful. So I started by first making a project. The nice thing about making projects is that it contains the memory of what you're doing. So you can start working on something and not have it bleed into the grocery list that you made or the car advice you asked for or the shopping advice you asked for. None of that's getting pulled into your project. So making projects is really nice for making a contained silo of thought for everything that you're doing. So started that, put it on voice mode. I don't know if you guys can hear this. Hello?
I can hear you loud and clear. If you've got something in your mind, let's talk it through.
All right. So I'm not going to do a demo of how voice mode works, but essentially I just talked this prompt that you're seeing on the board into there. And specifically, I chose deep research mode. So one of the options in there, you can hit a plus and you get different options for what kind of thing it runs. And one of them is called deep research. Deep research is an agent that just goes and researches an idea for you. So into the deep research, and my decades in academia make me cringe at how much text you're going to see in all of my slides, but it's a prompting talk. So it's just every slide is just text so that you could go and see these prompts. So please forgive me, my internal presenters cringing, but all of these have to be prompts because these are what we're putting into the AI. So I talked this. I said, I was watching Kyle's talk about WUI boundaries, and it made me think this might fit Mandelbrot's coastline idea. Can you investigate whether wildland-urban interface boundaries follow fractal scaling like coastlines? Please look at the theory behind fractal perimeters, possibly mechanisms that generate these patterns in landscapes, any existing literature on WUI or patch boundary geometry, methods for measuring fractal dimensions, relevant spatial data sets, and propose a few testable hypotheses and simple experiments we can run to evaluate the idea. Tell me everything there is to know about these two ideas and how they're similar and how they're different. So it thought for 19 minutes. It did 311 searches, and it made me roughly like a 15-page PDF report on everything that it had learned. So that's us going forward, right? So that I just say that on my way to work. By the time I get to work, this PDF is ready and waiting for me as sort of the background of everything that I need to know to chase this question. Okay, so that's where we got first, is I just asked for deep research via chat, via verbal chat. This is it's 15 pages, so I didn't give you the whole PDF, but you can roughly see where it started. It talked about the background of Mandelbrot. It talked about what the British coastline was in terms of fractal dimension. What is a fractal dimension? What are other things like the FragStats package that a lot of you are familiar with that might deal with this, that might help me test this. It goes on to, it did, 311 searches across a big, did a big literature search for me and just gave me a baseline to go from. So in our Act 1, when we talk about the id, this is our starting point, is we now have, that was my first interaction with the id. The id is just my main conversation. My central interaction is always going to be with the chat platform and the id. As we go to other tools, going to use it to write the prompts for us to help us move things forward. Okay. So, so I went to the id. Oh, let me, okay, going to go back. So I went to the id and I dumped in that. So I asked that question. It made the report. It can read the report, but I also like to download it and give it back to it and have it read it as new context. And this gives us the idea of a context window. So this used to be short, how much memory in session memory one of these things had. It used to be really short. Now it can be more than 1 million tokens for one prompt. So you could put in the entire Lord of the Rings series and still have Room for the Hobbit in your context window. All right, this is like, you could put a lot of context in there, and this is what it's drawing upon. We'll get into this a little bit, but you could start dumping information in right at the beginning. Okay, so here is our functional model for how we think about interacting with this thing. And I've talked about this in previous talks of these simulacrums. So the fundamental idea here is the transformer is a translation model. It wants to translate between two things. What are those two things? Well, they are hypervolumes of those data that we talked about. So those points in space saying these things are like these things. When you open up a new instance of things, you get two generic personalities. And so when you ask it for a prompt, it's translating an idea between those in the most generic way possible. This is usually a markdown list with a lot of bullet points. You guys have seen a lot of these like first pass questions to the thing. It's really generic. The best way to start getting better results out of your prompts is to start manipulating those things. And every single prompt you give manipulates it. So opening up a fresh one, they're fresh, and every single prompt you give warps those in different ways and changes how they interact. So when you're using the prompts, the very first thing you want to do right up front is establish who are the players that are talking to each other in as much detail as possible. So I am a scientist. I'm writing a proposal to the NSF. So I now am one personality. The NSF is now the other personality. So it's now drawing upon everything that it knows to work those two spaces. So that when you say, give me an email, or give me a proposal, or give me a figure caption, or give me a list of citations, it's now thinking about those two entities. So you want to start warping those as quickly as possible and know that there are two of those, and then there's a medium that you're sort of crystallizing the whole thing as like the email or the paragraph or the manuscript paragraph, or what is it they're actually producing to communicate between the two of them. So here's my example of how I then moved from this idea. So I took that and dumped it into the context window. And then I asked it to make me a toy model to help me understand the idea. But this context window, I did two different versions of this. I opened one fresh one and did this. And I said, in one prompt, my favorite movie is Barbie. And then we didn't talk about it. I just said that. And then I said, forget that. And then I went and separately asked it to say, I've read the report. or you've read the report, build a self-contained HTML prototype that lets a user explore where WUI boundaries behave like Mandelbrot coastlines. The app should generate simple landscapes, highlight the WUI boundary, let the user measure the boundary at different ruler sizes, and show the scaling relationship so a scientist could become convinced that this is worth testing with real data. So notice that just because I had said my favorite movie is Barbie, look at the name of the app that it created is the Barbie Dream Coastline. And then separately, I went and I said my favorite movie is Oppenheimer, and it made me the Oppenheimer mode with like camouflage motif. So this is after I gave it a fact about myself and said, forget that fact about myself. And then I went and asked it to do something, and it cannot forget. And it does not have a running memory. It has a warping space. So you give it a fresh version of the space, and the longer the conversation goes, the more that warps in the particular way. And you start a new conversation and you start with a new one, and it warps and warps and warps. It's going to be very frustrating for people who get in one chat and work the thing and work the thing, and it's like perfect. It's warped like exactly how they want it to give the answers that they want for the thing they're doing right then. And then the context window runs out. You filled up that one chat window. It starts to get really slow. It stops responding. You have to give up on that one and go start a new one, and you start a fresh one, and it's not warped the way you want it to be warped. You start fresh. You have to spend a bunch of time getting back to that. Yeah.
How does this interact with the fact that ChatGPT now uses your past chats as text?
Totally.
Yeah, like
So that's why you would make a project to quarantine from that. So when you open up a fresh new chat that's not in a project, it's using whatever the context window is that it's made on you and building that into that. They have personality injections. So it's one of the options you can go. It brings up this form. You go into that form and fill out all this information that you want, and that gets injected into a project right at the beginning and gives it that initial personality if you want that to happen. But essentially that applies mainly to the ones outside of projects. And so if you make a project, you're quarantining that.
always
Unless, no, like when I just ask silly questions around the house of like, should I fix this or should I fix that? I let it remember all of the other silly questions that I've asked and use that as a context. So I sort of think of one of the projects, the not project, as the me one, and it sort of stores the silly me stuff. Yes. Yeah. This is not in the free version. Okay. Okay, so in the plus, hit the plus, and down below that, there are a couple options. One of those should be deep research. If it's not, hit the apps. It's a little apps one, and it should bring up all the apps that you could do, and deep research should be one of those.
Take like work in deep research, and then I could take it and make a project, and feed it to it, it's relatively deep research.
Yeah. So they are in the process of forking things that used to be embedded as prompt codes into self-standing apps. Deep research was a code up until just the thing that was like released a week ago. It was previously a code that you would give it. So in the prompt, you would inject like do deep research, and it's prompting it to do this reason on top of thing, but it would never do 300 searches, and it would not make a report. It would like do the deep thinking thing, and it would do a lot of that. But so I'm sorry, that's not working yet. It's in the midst of rolling out. So yeah, right. Yeah. The alternative that I used to do before the deep research feature was open is first go in and say, make a list of all the things I should research and make a list of 10 or 15 prompts. And that now is a for loop of prompts. So you take that whole prompt and put it in again and say, run through these prompts and make a bunch of documents and produce them. No, no, yeah. Yeah.
I've only done chats and I've run into that problem where I guess it's out of memory.
Yeah.
And so I started doing like, I've never used projects before. Before working projects, I'm still running for that same problem where
Yep.
when you set a new chat, it needs to know what you're talking about.
Yep, exactly. You can say, go read all the other threads in this project, and it has access to everything else in that project, and you can read through all of them, pick up where you left off. Yep, yep. But it usually uses some compressed version of all that. Yeah.
Have you played much with like pairing chat to Claude to all these models that are out there?
Not too much. I usually use OpenAI's version myself, and Tyson usually uses Claude, and so most of it is about us arguing in meetings about which one did something better. But the reason I chose to stick with this for this presentation is that CU is adopting the OpenAI platform, and so I wanted to give everybody the stuff that we're going to soon have really good access to. So, but the Claude is supposed to be, have a slightly more playful voice, and it's supposed to be slightly better at coding, like clean code in the first try. Okay, so so we learned that, yeah, once you start warping this thing, it's off to the races, but also that it is pretty cool. Where are these guys? Okay, so here are these apps, and they work. So chat produces these in what's called the canvas. So in your main chat, you can have it in the chat, or it has this built-in tool called the canvas where it can start pushing stuff to a little bit of like a templated Word document. That's easier for copying and pasting. So in our prompt, we said, make this self-contained HTML. Self-contained means don't have a bunch of dependencies that we can't build for you here, just like write code that does a thing, and have it in the canvas. And so it will write all of this in the canvas, and you can download, and it downloads an HTML, and you just drag that. So this is a file that I dragged into the bar here, and we can compare the Oppenheimer one to the Barbie one. So here we have this log-log linear relationship. Here we have a WUI, and we can adjust things like how patchy is this, how smooth or how rough is the thing. Do we actually show the ruler grids? We can make less vegetation. So now we don't have a WUI because they're not touching. More vegetation. How much development is blasting out into the WUI. And finally, what is our grid size for the simulation? And you can see our graph changed a lot. So we don't have any relationship when there's not a WUI because there's no boundary. But if we all of a sudden make it so they interact, now we switch to this log-log linear relationship. So cool little toy that so in the scientific process, we had an idea. We got through the initial lit review of telling us what has been done and what hasn't been done. Now we're playing with what should some hypotheses be? What would be some ways we could interact with data? We could play with different things. Okay, so personality, I decided now that we had this thing built out a little bit, maybe I'd go and try just a Sora prompt. So I gave Sora the document that we had produced, the background document, and this.
So the length of a boundary depends on the size of your measuring stick. Trying to capture it out here? Yeah, it's like chasing a snake made of houses and
You guys
trees.
can't
Watch what
hear it.
happens as I shrink
Sorry.
it. The computer agrees. Smaller stick, longer line. Turns out when that boundary wriggles like this, every smaller ruler catches more of its secret twists. Load of numbers later, and this is what we get. A line that keeps getting longer the closer you look. And now it has a home in the literature. The smaller the ruler, the longer the boundary. Kind of beautiful.
Well, sorry guys. Can't hear it, but sorry, I made a cool video of our id character. Okay, so point one was this personality, what we're calling a personality, which is the warping of that space. Second, This one is the one that is really, really, really important for doing science, is that it's a probabilistic model. When you give it a prompt, it is giving you an autoregressive, probabilistic, best guess answer to how that should end. It's predicting the future based on what you gave it, probabilistically. If you think about a normal bell curve, the middle answers are very boring. They're very dull. So when you ask it initial questions with the generic personalities, it gives you dull, boring answers. If you ask it to make poems, it gives you dull, boring poems. It's dull and boring at that medium. And most of the time in science, we are looking for the low probability stuff, the low probability explanation of a thing, the low probability connection between two things, the low probability way of saying something, because it's all jargony and big words, and it's something that, according to the corpus of all language that's spoken, we're out here at the tail. So in probability space, if you want to be at the tail, you have to sample more, and you're going to get more wrong answers before you get a right answer. It's still just probability space. So if you hit the middle, you're getting a really high probability answer. It's probably a really generically good answer across a lot of specs. As you go out here and ask it stranger and stranger and stranger questions and start bending those personalities to more and more and more niche, obscure spaces, you have to give it iterations of things. Okay, so how do we translate that into prompts? Well, here's our id. So again, we're in id space, and he's daydreaming about fractals. And we're going to say, I want you to go come up with some hypotheses. But we're going to take an intentionally probabilistic approach to this by saying, give me a sample of these things. Here I'm just doing 10, but you could say 100 or 1,000, or like, try to go out there and give me the distribution of possible hypotheses out there. So I know which ones are the boring high probability, which ones are the lower probability ones, right? So this prompt right here for the question, why might Wooey boundaries show coastline-like scaling, generate 10 concise hypotheses and place them on a 1D probability axis from high to low plausibility. Return the results as a simple table with columns, short hypothesis label, probability ranked from 1 to 10, one-line mechanisms, and one-line test. Then add a compact plot showing the hypotheses positioned along the probability gradient from high to low. So it's like, go out and explore these hypotheses, report back with like the distribution of possible hypotheses to this question. Once we've generated that, I didn't show you that document because it was pretty big, but you guys can see it in the repo in a little bit. So we then generate this whole distribution. It's like, okay, where from that distribution of hypotheses do we want to sample? Where is our sweet spot? And we've gotten to the point now where we actually want that modal hypothesis, right? We want sort of want the most common thing that's easiest to chase and test right now. We think we're onto something. So I said, narrow the hypothesis space to a single best hypothesis that connects directly to the data sets we want to use. So I prompted a little bit there. I did a little side quest here to say what would be some possible good data sets for testing this question. And so in this prompt, I now am narrowing it specifically based on what I think we might test. So there was a human intervention point here that is pretty subtle, which is just like me saying, okay, well, out of the universe of possibilities, which ones do I actually want to spend time chasing? So narrow the hypothesis space to a single best hypothesis that connects directly to the data set we want to use. Open street maps, building footprints, and satellite-derived vegetation or land cover rasters. Choose a hypothesis for coastline-like scaling in Wooey boundaries that can be represented as the interface between buildings and vegetation across multiple spatial resolutions. State the hypothesis briefly, explain why it's the best match to these data sets, and then use the Python tool to run a small sanity check simulation and generate a log-log plot of boundary length versus measurement scale. So I asked it to do a lot of things, right? So it's going to go through, break these up into steps, and cruise through them. So here's what it returned. First, the hypothesis that it thinks in form of an if-then statement. If buildings and vegetations are more spatially interwoven across the landscape, then the Wooey boundary between them will become more geometrically complex, and its measured length will increase more rapidly as the measurement scale becomes finer, producing stronger coastline-like scaling in the data. So what are we saying? So here are possible spatial patterns. And the more clumped they are in large patches, the slower the slope is of measurement. So here it's like, if there's a jagged coast and I'm using a long ruler, I miss a lot of the jagged inputs. I go in, I measure, and I get a shorter distance than if I get a smaller ruler, I measure more of those imprints, and it actually gets a longer distance. So it's like, what is the relationship? How quickly does that change? And it turns out that when you clump, it doesn't change as quickly as when you don't clump. And so now we're building a quantitative hypothesis already of like, what do we expect in the data? These are all simulated. This is us just playing with the idea of like, if I go out and start some bullets data, what should I expect to see? And how would that fit the hypothesis? So now we have stumbled our way in with not very many prompts. We've stumbled our way into a pretty good hypothesis with a pretty good way of testing it. And now we want to go see what the viability is. So for us to go do some more work, we're going to talk about the third thing about our id, which is that it has a lot of built-in tools. When we go to the ego is all about using tools, but we're talking right now about built-in tools that you don't have to go outside to link into in any way. They just are automatically built in the thing. It's using it in the background. And if you know that they're using it, you can get better outcomes. So one of these is their reasoning. So a single run through a transformer model is like a prompt and a response. And a couple of years ago, that was the totality of what you got. And they were trying to figure out how to stack those into reasoning. We've now moved into all of them are full reasoning models. So when you give it a task, it first sends it to one model. That model starts thinking about a strategy. It might go through 10 or 15 prompts thinking about what the strategy is and come with a strategy, break that up into subparts, and then send those to different prompts. And it might work through 100 or 200 prompts in answering a question, depending on how big of a thinker mode you have turned on. And you don't know these are going. So the cheaper the model you have, the less of this reasoning you're doing. Most of the time when you pay for bigger and bigger models, most of what you're paying for is the ability to do more reasoning. So if you do the full pro model, they don't have any limits. And so there are people who will run a single prompt that'll run for like 6 or 7 hours as it's going through and just doing all kinds of different stuff. The model that you have access to is probably limited to about 10 or 15, 20 minutes of how much reasoning it's willing to or able to do. And so that's sort of the extent of what you're able to use there. Context windows we already talked about, but the context windows are getting longer and you're getting more control over what you inject into the context window at what time. And then the big ones, so a couple of years ago, it was really bad at math. And it's still bad at math if it did it, but it no longer trusts itself to do math and it always asks for help. So it uses Python or it uses MATLAB in the background. So if you ask it what's 2 + 2, it gives that, it makes a Python, in the background, it makes a Python code, runs it, gets the answer from Python and gives you the answer back. So it's going and using a calculator rather than trying to do it itself. So all of a sudden now it's gotten really good at actually doing math in a really good way, but not because it's doing it itself, but because it's using these tools in the background that you're not seeing. The canvas I already talked about, which is the little editable Word document that pulls up in the edge for you to use if you want to. We're going to talk about one, which is the agent. So so we came up with our question, we did our lit search, we played with some toy models. Now we're ready to start playing with some real data. If we've even identified some possible candidate data sets, and now we want to just go see if those things are actually available. So if I take this prompt here, and so in chat, I'm going to go down here and under more is agent mode. So in agent mode, I'm going to put in this prompt, which is, and the prompt is, so using the same workflow as our earlier successful prototype, run a small sanity check on the 2 core data sets. Open street map building footprints and satellite land cover rasters. Use Python tool to load a small test data set, confirm both data sets are open correctly. and report basic metadata and make a quick overlay plot so we can verify that they are usable for WUI boundary extraction. If you can't load, at least verify that the data sets exist and they should be downloadable from a virtual machine. So what am I thinking here? I'm thinking, okay, it's going to go and try to pull little samples of these things. Those things might be too big, or it might run into all the problems that I know you run into getting real data. So I'm asking it, go try these things. Don't just fail if they're not working, because I expect a few of them to fail right at the beginning. Just report that back. Try to just tell me what the status of the whole thing is. Now, the thing about agent mode, if the Wi-Fi is good enough here, it'll show us. It actually shows you it's going to go search the web, but not in the background. It's going to like pull up the window. Yeah, here we go. So now you have opened a virtual machine. The agent is a virtual machine. It has full control over that little virtual machine, and it's going to town. So it was in the terminal. It was trying to do stuff. Now it's searching. It's actually going to the websites that you would go to check out these data sets. It is trying to download those data into its own little virtual machine here. Okay. So in the interest of time, I'm going to keep going with my presentation because you can just see sort of what the outlook's out. This is what it outputted. So the tool went and it found those two data sets. So you can see it found world cover, it found overpass. It was able to get both of those. It was able to extract vegetation. It was able to then plot a sniff test on our thing. And what are we again seeing? We're seeing a log decline, just like we've been seeing and we were expecting. So here it didn't pull very much data, but we didn't have to do anything. We were just asked to go and try some stuff. Okay. So now we feel like, okay, we have a method. So we've gone from idea through hypothesis generation, through discovering what data we could use, and now we have a method that we could apply to that. So let's now go and try to write a Python script. Now you're going to have this problem of where do you do compute? We still have access to Cyverse, and Cyverse is going to be a part of this when you want to do things that are compute heavy. So here I know I'm going to have to go to Cyverse and run this on a big Python machine that has a lot of memory and a lot of compute. And so what I need now is a prototype script to go and just see if that can work. Can I put that in and have it download all those data and do all those things and just give me a working prototype script that I need? So here is what I'm asking. So I use, again, I'm still in id. I haven't moved out to other tools yet. And I'm asking it for help making that script. So it did that. It made that script. I put that into Python in Cyverse, and this is what I got out. So here is a bounding box around Boulder, and the points are where it sampled. So it took a random sampling point from those things. From there, it pulled within that buffer, it pulled boundary buildings, and it pulled veg. It calculated the boundary between those, and then it said across these resolutions of 3 different satellite data with different resolutions, how did they get different answers? And here we're starting to fill in a statistical distribution. So again, you're like, cool, that's pretty sweet, right? We get the prototype data immediately works. And then I went back and said, okay, like let's scale this up. Like I want it more than just Boulder. Can you now scan through a lot of different places? And I started this yesterday and it was not done. Yeah. So here it is. Here's this code and it has gone through and done 100 points in Boulder and Denver and Colorado Springs and Salt Lake City. And it's currently working on Boise. And it has this list of 20 cities that is going through, sampling these, testing the WUI boundary, and again, testing it and trying to make a more powerful version of that line. Okay. So on to move to the ego. The ego is the thing that wants to get things done. This is the worker bee. This is the technical operator. The thing is, the ego is not a very good writer. And it's hard to write prompts for the ego. So so you're going to see it through both the ego and the superego as we go through them. I'm always going to the id and asking to make the prompt to give to the other thing. So the central like thinking, all of the memory about where we're at and the contextualization and the understanding where we're at and the articulating how all the pieces are coming together is still happening in the id with me. And then we'll say, okay, make a prompt for Codex or make a prompt for Prism that will do this, 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 and this, copy and paste that over and have the next tool do a big thing. But it is better at writing prompts than you are when it comes to like communicating these ideas to the other tools. So first thing we're going to do is contain the chaos. So just like making a project in the id controls the memory, as we start moving out, we need to start controlling where does all our code go? Where does all our documentation go? We need a central place for that to happen. The thing I really like about Codec is that it goes to GitHub rather than doing it on your own machine. Some of the other, so there is even like the Claude app that you can get on your machine or the Claude desktop that you can put on your machine, and it will do all of this on your local machine. It'll get access to all your files and do stuff on your machine, operate your machine. Right now, we're promoting cloud. It's a lot safer. It's a lot more contained. So here you can do all of that. It's just think about it as the repo, again, as this contained place where all of your work happens. So I made a repository for this from a template. So on the easel GitHub, we have a bunch of templates. I took one of those templates and just made a blank. It's the basic, most blankest repo you can get. And now you hook up Codec to that repo. So let me show you what this works real quick. Looks like. Okay, so in it's frozen. Okay. So here's what Codec looks like. How do you get there? In this left bar over here, you can see, oh, here's deep research also. Deep research on the left bar, right below that Codec. If you click on that, it opens it in a new page, and it's just an app that looks like this. Here, notice that right here, I have chosen the CU ESL WUI boundary repo out of all of the repos that I've hooked up. If you need to hook up a new repo, you go to Manage Environments, Create Environment. I'm going to go look in the CU ESL, and this shows all the things that I could link. And I could link up a new repo if I wanted to. But I've already linked this one, so I don't need to. So here, out of all the repos that I could choose, I say, okay, I want you to choose the one that I made. And when I give it a prompt, so give me a summary of this repo. Every time you give it a prompt, it does a pull, a GitHub pull of the whole repo. It reads through the whole thing. Then it takes your prompt, makes a strategy for what should happen. And then the thing it produces is a GitHub pull request. So here is one I did this morning, which was to take the draft of the paper and add it to the website. And so I said, I just added this to the repo. I dragged the paper directly into the repo. And then I said, it now exists. Can you add it to the website? So I went through and it did some stuff and it tried some tests and it says I'm done. And it says you can go create a PR. Here, if I look at the PR, it's actually added these 4 lines, which are take that asset, that PDF, and just add it to the main page. When I go to view that PR, it takes me to GitHub. And here I get a PR page, a pull request page. It has run some checks to make sure it's good. And it's saying, all right, we're good to go. So we're going to merge that pull request, confirm the merge. And now the things I have done in Codec have been applied to the repo. If I come up here, I can look at the actions and I can watch it doing it's now being applied, being injected into the repo. All right, so Codec, again, it is a chat. It's the same transformer. It's just been trained on code and orchestration of repos. It is not a very good writer. If you say go fill the website in with content, it's going to fill the website in like it is code documentation. It's going to be single sentences and not no narrative, right? So you want to go to the id, have it make a nice narrative in a prompt that you can get to codec, and codec can go add it to the website for you. Okay, so once we have codec hooked up to the repo, we're going to start using it as a memory tool and adding context. So the first thing, let's create some memories. Let's give the repo all of the knowledge that the id has already learned. So this was within the id, within chat, you're going to say, give me a prompt. So this prompt is for chat to give you a prompt for codec that takes all the information in id and make this project context markdown document. So the agents read markdown documents. That's their preferred documentation. So in the repo, if you just start adding markdown documents, it's going to read through that at the beginning, and it's going to understand that. So this is really helpful. Like, go do a literature search, make a markdown document with all your conclusions, and add it to the repo. And so here we're taking everything we've already learned, making it a markdown document, adding the repo, and now the agent can see it. Yeah. I would do, yeah, codec is not great at literature search. It's great at coding. So have it code. Okay, link to compute. We already saw that I opened Cyverse to do the big compute. It has a link to GitHub. So Cyverse, which is up here, has a link to GitHub. So I can push and pull. So if I make edits to here, I push to the repo or pull from the repo. Here, down here. This is the website. So let's say I pull the Cyverse, I make some changes to the code, I push back up. The robot, the ego can then read that and make some updates to the website and change the website documentation so it matches the code changes that we just made. Or you can come in here and have it make some new code, some new functions. They get dumped in here. You go pull them in here and run them as part of your. Okay, so here is that codec. We choose our thing, we make a prompt. It goes, it does thinking for a long time, and it'll come back. You can do these in parallel. We just went through and added this. If you guys want to go to the repo, here is a QR code to look at the repo. You can now see it's full of all kinds of stuff that the robot has stuffed in there. It also is the CU ESL GitHub page, and it's the WUI boundary repo. Okay, so now that we have this idea of dumping documents in, we can make a specialized document. Agents are always going to look for this agents.md document. So you put this in the repo, and any generic agent that plugs into the thing, this is different than context. This is directions specifically for it. So do streaming data instead of downloading data. Talk to me like this. My name is that. We're doing this for research, so do these rules. All the rules that you want for the agent, put them in the agents.md doc. Then every time it pulls the repo, it reads that first, and it uses that as its rules of engagement for your prompt. So here's a long prompt of just the rules of engagement. So this again is a prompt for chat for the id to make a codec prompt that has all of this information in it that would then make the agent MD.
And then you just manually copy, chat to
into codec, the prompt. So yeah, you say chat, give me this prompt, or give me this prompt, and it'll make like in the canvas, it'll make like a 10-page prompt. And you copy that entire prompt over into codec, and codec will then spend half an hour going through all of those directions and doing all of the things that the prompt says. There's this movement in Silicon Valley. These are all jargony words, but spec first development. it used to be that you wrote code and then eventually the code worked and then you documented what you had done. But that was because your effort was going into building the code and you were making sure the code worked before you wrote down what it was doing. Now, since the robot is doing most of the coding itself, most of your burden is getting the documentation done first. So you're sort of doing this backwards and you're saying, okay, I'm going to make a spec document. I'm going to perfectly outline how the finished product should work down to the T, how variables should go in, what those variables should be named, what data formats they should be in, where they should be stored. You go and work out all the details, and you can go back and forth with the id to do this, but it's like, go make the directions document first, then give that directions document to codec, and it'll go and implement all the code in all the different functions and all the different ways you need to do it exactly to where you did it, what you said to do. It'll try to implement that as faithfully as possible. Okay, so in the repo, I had the website. Again, I'm controlling the website with codex prompts. So I can go into the id, I can give it a prompt to give me a really great codex prompt, copy it into codec that goes and updates the website. So the website was already in the template, so I didn't have to go and build a brand new website. I just had to redecorate it. So a lot of this is just about redecorating. And here's the QR code if you guys want to check out the website. It also is just linked from the repo, but it wound up being, it took all the text that we had been building and put it out here and essentially started making our first draft of a manuscript. So this is when I like to start to build the narrative. I like to use the website, again, because it's so connected to the code. It's so connected to the outputs that are already coming out of the code. You can use codec to populate it with a bunch of text pretty quickly, and so you can start iterating on what your thing looks like. Finally, we have tests. This is something that you probably have never needed to do because you never got high enough level of computer engineering to need to do this. But now that you've been accelerated up a couple flights of your professional trajectory in terms of computer science, now you have to start thinking about things that sort of advanced computer science people have worried about for a long time. And they use tests religiously. Tests are a thing you put into your repo that every time you push changes, they test that and say, does it pass or fail this test? There are no generic tests, really. These are tests that you would want to do. So the test that I added is one that's called Playwright. Playwright is something that goes and clicks around a website for you. You give it a website and it'll go and try to click every single button, scroll every single thing, and report back if something's not working. So this is a really nice test. So I added a Playwright test since we were editing the website. So now I don't have to watch it do this. I just go, if I make an edit to the website and I push that in the testing phase, it goes through and makes sure all the clicks and it'll report back like, oh, you actually made an error and this button doesn't work anymore. And you say, go fix that button, and then fix the button. Okay, and then I got my repo all like I want it. I have the narrative in there. I have the agents. I have the code working. The whole thing is looking really good. I'm ready to make it really usable. Now I can make it a Python package, and then I can start using it really easily. So I have all that stuff in there, and now I just give it a prompt to go make this a Python package, and now it's easier. Next time I go to the VM, I just load in the Python package and start running the functions, and I don't have to do much. All right, the superego. This is your professional veneer, right? This is the part that other people see, the part that, the flashy part that other people see. So what we're going to use here is a program called Prism. Prism is also an OpenAI product. And it is a LaTeX editor. A lot of you are not using LaTeX, you're using Google Docs instead. Google Docs there is an app that lets you do similar things with Google Docs, but the university controls our Google Docs and they have it all locked down. Well, let us do this. So I'm showing you the LaTeX version instead, but you can imagine doing this with whatever your writing software of choice is if you can get the right permissions to hook it all up. So here we have the rendering of the document on the right. LaTeX is a code-based renderer. So in the middle is the document that actually produces all that. So this is your code. And then here's your storage. And I have a chat built into this, and I can do a couple things in tandem, right? So I've already built this whole document, and the citations are all pretty good. I've already checked citations a couple times, but I don't have my AI transparency statement in yet. So here I asked chat to make me a transparency statement. And say add this. It's disconnected for some reason, but luckily everything was already done. That was just for demo. So here though, you have this rendered document on the right, edit here, and you have context here, and you can use the chat to pedantically fix stuff about the document. Prism, again, is a terrible writer. So don't ask Prism to write content for you. It's going to give you very nicely formatted short form stuff. The thing Prism is trained to do is make perfectly formatted copy. So it's taking ideas and it's really thinking about, is this thing formatted perfect? Is the math right where it's supposed to be? Are the figures where they're supposed to be? Is all the spacing and the margins? It's thinking like a copy editor. Like, is this thing ready for sharing? So you still are going to go back to the id, give it prompts, have those prompts be specialized for Prism, and then copy them over for Prism. Okay, so first thing I did was you open a Prism and say, well, we put all this stuff on the repo. You can see the repo. Go check the repo and pull everything that you can find from the repo. The repo has the project, the context, all the citations, all that stuff. Literature review. Prism is really good at literature review, but the id is also really good at literature review. They're both getting really good about finding good citations. There's still a question about whether they can properly format the citations in the output. But in terms of finding citations, think about things outside your field, things outside your language, things outside that are no longer published, that it can still get access to. It can really help you find a lot more about the literature. And so have it find those things, have it try to track those things down, try to have it contextualize those things for you. One thing that I had Prism do is I put this prompt saying, go check every citation against the statement. So tell me the statement and the citation and whether they're the same or different. Identify our readership. So now we need to say, where are we going to send this thing to? If we're sending our final copy, we need to send it to someplace. Well, most of the journals have LaTeX templates for you. So I said, okay, we're going to go for this journal FIRE. So I want you to pull the template for FIRE, and I want you to pull the author guidelines for FIRE and make those. So there's now a markdown document with the author guidelines in Prism, and it applies the template to the LaTeX. So it already starts to look like a FIRE document. Writing, this is just a reminder that Prism is not very good at writing. So anytime you want actual prose, you need to do them yourself, and if you want to practice them, go back to the id and don't have Prism. This Prism's just not very good at it. So I then had it draft some text. So this is me going into the id, giving this prompt to id, having it make a draft in the form of a prompt that I can give to Prism to then inject that into the Prism. Citations. So again, Prism is set up for you to be pedantic checking of the citations, but it's not Zotero. So a lot of us, I'm still using Zotero as the citation manager because you can have multiple people check the thing and it's a lower prone to error. But the citations are getting much, much, much better than they were a year or two ago. Here's that citation audit I was talking about. I'll just go through and tell me how well we did and how well the citations match what we're saying. And we have to end with this point. We're not almost end. There are no excuses for what the AI says on your behalf. So I think this is where there have been the most problems so far, is that maybe you got a citation wrong, or the LLM said something different than you would say it, and you own that because your name's on it. The LLM cannot put their name on anything. So you have to verify everything at the end. So you don't have to verify every step of everything that you do, as long as you get to a point where the condensed form, you really have verified it as a human, because you're putting your name on it. So it's not, the LLM doesn't have any accountability here in any way. You have all of the accountability for what you say. So that is the main thing here, is like, you have to verify this veneer before you send it out. And maybe if you have a collaborator and you both know you're in an innovative form and you know you're using LLMs, that's one thing. But when you actually go to publish, your name's going on the thing. So here I had him give a conference presentation.
This satellite image shows
But you can't hear it.
Reserve against a growing town.
He's talking about all our results.
Sharp balcony forms where homes meet the trees.
Okay. Okay, the online people can hear it. You saw me add this as a prompt, but the transparency and AI use statement, these are becoming mandatory in most proposals and most publications. And it's important to say, like, what did you do and what did the AI do? What was verified and what wasn't? How were things verified? How weren't things verified? Things grow. These technologies are growing so fast that GPT-3 and GPT-5 are wildly different technologies. So it's important to say, like, which one of those you actually used. And with that, we're all done. I have maybe 2 minutes for questions, and I'm happy to stay after. Questions, comments, concerns, arguments? Yeah. Yeah. Right. Yeah.
I think a lot of this is testing and prompt is not nonsense.
Yeah.
So I think sometimes this is probably conceptually more but
yeah, totally. The audience here is professional research scientists who are potentially thinking about large frameworks for doing big data movement and sort of like want to be using this as a tool in their workflow. But yeah, it's assumed that you have a background workflow that's motivated by you. And the AI is not a good enough scientist to be motivating your workflow yet. See if I had some maybe chat questions. Okay. Yeah, sorry. The question was about maybe non-professional scientists or undergrads how would they be able to use this? So my comment. How much effort goes into reviewing your outputs from the codex prompts? Okay, the question was, how much do you review all of the code from the codex prompts? I think this depends on what style of coder you are. I am a data scientist, and most of my interaction is at the graph phase. So I need to get to a plot, then I can look at the trend on a plot or the relationships in a plot, and that's where my brain is able to engage. So usually I am not worrying too much about the code, and I'm looking at the plot, and if the plot is doing something really weird, then I go back and say, what did the code do? And then once I get something that's really settled, then I'll go back and see everything that happened. But I am not checking every step. I think that particularly at the beginning, you're going to check more because you don't trust it as much. And you think, well, I can't possibly be doing this or that. As you get better at making prompts, it gets better at doing predicting what you want it to predict and doing and responding the way you want it to respond. And you start trusting it more, and you stop checking it every single time, and start doing like benchmarks and built-in tests and things where it's checked automatically. All right. Thanks, everybody. I think we're out of time. Thanks for coming.